So today we're going to be solving systems by substitution. We just got done graphing, solving by graphing. So our second method is to solve by substitution. You can use this if it's not easy to graph, or this could also be something that you can just use if you want to set it up this way. Maybe you don't like graphing. So our steps for this are to solve for one equation, for one variable. Replace that, whatever you just got, into the other equation to create a problem with only one variable. You're going to solve that equation that you just created for the one variable, and then plug it into the first equation and solve, and we're going to write our answer as an ordered pair. So remember, that means that they're going to be an x comma y form. A solution to these still means that if you were to graph it, the point where it crosses, where our two lines would cross. So we have y equals 2x plus 7 and y equals 5x plus 4. Since we have y equals for both of these, we're going to be able to take this and substitute it in for what y equals. So instead of saying y, we're going to substitute this in as 2x plus 7 equals 5x plus 4. And then we're going to solve this for x. Now we only have one variable and we're able to solve this. I'm going to move my x's first to be able to get a positive coefficient. So I subtracted 2 x's, subtracting 4, and last step is to divide by 3, and we get that x equals 1. Now what we're going to do is take that answer and substitute it back in to one of the equations for what x equals to get what y is. So we're going to take this now, that's what x equals, and we're going to plug it in. I'm just going to choose the first equation. It really doesn't matter which one you choose. So I have y equals 2. Instead of saying x, I now solved that x is 1. So I'm going to plug that in, and we're going to add 7 to it. So 2 times 1 is 2, plus 7 is 9. So we got x equals 1 and y equals 9. So we're going to put all of that together to get a solution of x comma y, 1, 9. And for it to be the solution to the system, remember that means that we have to be able to plug it into both equations and it be true. So 2 times 1 is 2, plus 7 is 9, so it works there. And 5 times 1 is 5, plus 4 is 9. So it checks in both of them. So that's our solution to the system. Now in that equation, both of them were equal to the same thing. They were both y equals, but what happens if we don't have that? Okay, all we're looking for is one equation to have one variable completely by itself. So if we have x plus y equals 0 and x equals y plus 4, the first equation doesn't have x or y by itself on one side. We could solve for it if we wanted, but since this second one is already what x equals, we're going to take what x equals and substitute it in. Instead of saying x here, we're going to substitute in that y plus 4 and write down the rest of the equation, whoops, plus y equals 0. Now we have an equation in one variable that we know how to solve. Combining like terms, we get 2y plus 4 equals 0. And then to solve for y, we're going to subtract 4 and divide by 2. So this tells us that y equals -2. Once we have one answer, we're going to take this y equals -2 and plug it in. Now you can plug it into the first equation or to the second equation. Again, it doesn't matter. Since the second equation already has x by itself, I'm going to plug in there because it's going to make it go faster or less room for mistakes or errors. So I have x equals, instead of putting a y there, we solved and got y equals -2. When we add the 4 to that, we get that x equals +2. And so then we're going to write that in an ordered pair. X comes first, y comes second. That's going to be the tricky part about this, is making sure it doesn't matter which one you solve for first. We need to write it as x comma y. And you can check this in both equations. 2 plus a -2 is 0, so it checks there. -2 is my y, plus 4 gives me a +2 for my x, which is what it's supposed to be. So 2, -2 is our solution. These questions are going to do the same thing every single time. It's just going to be a different set of equations, different situation that we're in. This even works for things that have fractions with them. So if we have y equals negative 2/3 x plus 4 and 2x plus 3y equals negative 6, we have what y equals. So we're going to take what y equals and we're going to substitute. I'll bring my arrow this way so we can see what's happening. We're going to substitute it in for that y. Reading the second equation, we have 2x plus 3. We read it exactly as it is. As soon as we get that y, that's where we're going to substitute in what y equals from the other equation and finish off the rest of the equation here, the second equation. Now we're going to go through and do our steps to solve this. Since this 3 is in, this fraction is in the parentheses, I'm just going to go ahead and distribute that 3 in. So 3 times negative 2/3 x is negative 2x. And 3 times 4 is 12. And that equals negative 6. So technically I don't need this double sign here at all. But 2x minus 2x, those are going to go away when we simplify. And 12 equals negative 6. Well, that doesn't make any sense. Our variables went away, which is okay. Is 12 equal to negative 6? Since that is not a true statement, 12 does not equal negative 6. This is one of our special case scenarios. Does this mean that we have no solution or infinite solution if 12 does not equal negative 6? Since this is not true, we would have no solution as our answer. Okay, and that's allowed to happen just like it did in our other examples with graphing. We can still have no solution. That means that if these were to be graphed, they'd be parallel and never touch. Alright, let's take a look at this one here. 2x plus 5y equals negative 6 and 4x plus y equals negative 12. In the other examples that we've seen so far, every single one of them has already had one variable completely by itself. So we don't have that here, which means we have to do the work. Okay? You can decide which variable you want to get by itself in whichever equation you want to, but we obviously want to use the path of least resistance, the path that's going to be the fastest or easiest for us to do. So we're going to look for the variable that looks to be the easiest to deal with. So we have 2x, 5y, 4x, and there's a 1 in front of that y. Since that is the easiest, this with a y, we're going to work on getting y by itself. That means we have to do some work first before we can just start substituting in. We need to get y by itself. In order to do that, we need to get rid of these x's. We need to move them to the other side. So when we do that, we're going to get y equals negative 4x minus 12. Now that we have that y by itself, we can take this and we can substitute it in for the y in the other equation. Okay? That means we have 2x plus 5. Instead of putting y in parentheses, we're going to have negative 4x minus 12, and that's going to equal negative 6. To solve this question then, we're going to distribute. So 5 times the negative 4x is negative 20x. 5 times the negative 12 is negative 60, and that equals negative 6. Simplifying, we get negative 18x minus 60 equals negative 6. We're going to add 60, and negative 18x is going to equal a positive 54. We still don't have what x equals yet, so we're going to keep going. We're going to divide by negative 18 on both sides, and x would equal a negative 3. Now, we do have what x equals, but that doesn't mean that we're done with this question yet. We need to make sure we're going back and substituting this value in for x in one of these equations. And I'm going to suggest that you're going all the way back to the original equations just to make sure you didn't make a mistake somewhere in doing this stuff. So let's plug it into the second equation. So we have 4, we got negative 3 for for x, and we're going to see what we end up with here. 4 times negative 3 is negative 12, plus y equals negative 12. To get y by itself, we need to add 12 to both sides. Negative 12 plus 12 gives me 0. So now we're going to be able to write our solution to this in x comma y. So we got y equals 0. That means we have 3 comma 0, whoops, sorry, negative 3, 0 is our solution. Again, if we check them into the original questions, it still means that it should work. Okay, so 2 times negative 3, that's negative 6. 5 times 0, that's 0. Negative 6 plus 0 is negative 6. It works there. 4 times negative 3 is negative 12. Plus 0 is going to be negative 12. So it works in both equations, and that is our solution. So just make sure as you're going through with these questions that you're following our steps. Get one variable completely by itself in at least one equation. After you have that, you're going to substitute it in, solve the equation that's in just one variable now, take that answer, plug it in to find the other variable, and write your answer in x comma y ordered pair form.